Sprinting to the future of law. All we imagine as light, brightening our life through photonics. Part 5. Some operational and environmental concerns with photonics. In the previous part of this issue, we discussed some legal and regulatory issues with photonics. In this part, we will look at some operational, ethical, and environmental considerations with photonics. First is standardization and integration. Integrating photonics technology into existing systems or infrastructure can be challenging and require standardization. Lack of standardized components and protocols across different manufacturers can hinder widespread adoption of photonics. So establishing and adhering to industry-level standards is a priority. In India, the Bureau of Indian Standards (BIS) offers standards for various end-use products. Accordingly, a manufacturer or importer may be required to comply with prescribed product technical standard, observe labeling requirements, and obtain a registration for relevant photonics device. Another consideration is reliability and maintenance. Photonics systems rely on precise alignment and stable light sources. Issues like vibration, temperature fluctuation, and component degradation can affect performance and data integrity. Ensuring their reliability and functionality over time, especially in critical applications like healthcare or telecommunications, requires careful and preventive maintenance. Redundancy and backup may also be required to minimize impact of malfunction or physical damage. Weaponization and export control is another major consideration. High-powered lasers and other advanced photonic systems have potential for misuse in weaponry or malicious applications. Photonics technology, especially those with military or dual-use applications, may be subject to export controls. Now let's look at some ethical considerations. Ethical use of photonics technologies, especially in the fields of surveillance and artificial intelligence, requires special attention. In addition, ensuring equitable access to photonics technology is important to avoid deepening of the digital divide and exacerbating disparities among social strata. Bridging this gap through infrastructure development, affordability initiative, and digital literacy programs is crucial. Now let's look into environmental concerns. Some photonics technology may involve the use of hazardous material and rare earth elements. Producing and disposing of products with such technology may be environmentally harmful, including mining pollution and resource depletion. Sustainable sourcing, recycling, and proper waste management are essential to minimize the environmental impact. Energy consumption can be another issue. Some photonics technologies, such as high-power laser, require significant energy to operate, raising concerns about their carbon footprints. Biological effects of light is another concern. Exposure to intense light sources, specifically in applications like medical treatment or research, can have negative biological effects on vision, on skin, even at cellular level. Exposure to specific wavelength of light can also have adverse health effects. Ensuring the safety of individuals involved in operations or proximity to photonics devices is essential. Life on Earth has always relied on light for energy, but light now brings much more than energy. Through photonics, it is enabling technological advances that we had not even imagined just a few decades ago.